This is question number 11. We're told the curve C has equation y is equal to 2x minus 8 root x plus 5, where x is equal to or greater than 0. In part A, we're asked to find dy by dx, given each term in its simplest form. The question carries 3 marks. We need to differentiate both sides of this equation with respect to x. The first thing I'm going to do is rewrite this. I'm going to write this as y is equal to 2x, and instead of the root of x, I'm going to write this as a power. The root of x is x to the power of 1/2. So differentiating, on the left we will have dy by dx. If I differentiate 2x with respect to x, I will get 2. If I differentiate minus 8x to the 1/2, I multiply down by the power, so I'm going to have minus 1/2 multiplied by 8. Then we have x, and we need to drop the power by 1, which is going to give me minus 1/2, and differentiating a constant will give me 0. So if I tidy this up, we can say that dy by dx will be equal to 2 minus 4x to the power of minus 1/2. We can of course write this as 2 minus 4 over root x. So either way, that can be written as 2 minus 4x to the minus half, or 2 minus 4 over root x. We're now told the point P on C has x coordinate equal to 1/4. In part B, we need to find the equation of the tangent to C at the point P, giving our answer in the form y equals ax plus b, where a and b are constants. The question carries 4 marks. The equation of a tangent is just a straight line. For a straight line, we need 2 things. We need a gradient and a point that it goes through. We've got the gradient function, and we need to find the y coordinate of the point that it goes through. So if we first start with the y coordinate, y will be equal to 2 lots of 1/4. Then we're going to have minus 8 lots of the square root now of 1/4. The square root of 1/4 is going to give me 1/2. Then we're going to have plus 5. So if we consider now, we'll have y is equal to 1/2 minus 4 plus 5. This is going to give me that y is equal to 3/2. So we now have a point that it goes through. We have the point that it goes through, and that is P. P has the coordinates 1/4, 3/2. We now need a gradient. Dy by dx is the gradient function. So we can say at P, dy by dx, the gradient function, and I'm going to use the second one, will be 2 minus 4 over the root of x. Now if we consider the root of 1/4 is 1/2, this gives me now that dy by dx will be equal to 2 minus 4 divided by 1/2 is going to give me 8. So we can say that dy by dx, the gradient is minus 6. So we have a gradient, we have a point that it goes through. We simply need to sub this into the equation of a straight line. Using y minus y1 is equal to m, the gradient, x minus x1, we can go ahead and plug these values in. At this stage, of course, you can use y is equal to mx plus c. So we'll have y minus 3/2 will be equal to minus 6, and then we're going to have x and minus 1/4. If I go ahead and expand the brackets on the right hand side, we've got y minus 3/2 is equal to minus 6x, and then we're going to have now plus 3/2. All I've done is simply multiply minus 6 by minus 1/4. I'm now going to add the 3/2 to both sides. So we'll have now minus 6x, 3/2 plus 3/2 is going to give me 3. So we can say that y is equal to minus 6x plus 3. So a would be equal to minus 6, and b would be equal to 3. We're now told the tangent to C at the point Q is parallel to the line with equation 2x minus 3y plus 18 is equal to 0. In part C, we need to find the coordinates of Q. Let's just look at this line right here. What we've got then is 2x minus 3y plus 18 is equal to 0. I'm going to rearrange this in the form y is equal to mx plus c and evaluate the gradient. So adding 3y to both sides, 3y is equal to 2x plus 18. Dividing both sides by 3, y is equal to 2/3 x plus 6. We're only interested now in the 2/3, because now if the tangent is parallel to this line, the gradient of the tangent to C at Q will be equal to 2/3. What I'm going to do at this stage is simply set dy by dx equal to 2/3. So what we can say then now, at the point Q, dy by dx will be equal to 2/3, as that's the gradient of the tangent which is parallel to this line. Therefore we can state now that 2/3 will be equal to the gradient function. The gradient function is 2 minus 4 over root x. So 2 minus 4 over the root of x. At this stage I'm going to add now the 4 over root x to both sides and subtract 2/3 from both sides. That's going to give me now 4/3. So from this we can see now that the root of x will be equal to 3. We can square both sides of the equation and say that x will be equal to 9. At this stage I simply need to plug this back into the original equation to find now the y coordinate of Q. So I've got now that x is equal to 9, and I'm going to simply plug this in. So if we consider what we're going to have, we're going to have y will be equal to 2 lots of 9 minus 8 lots of the square root of 9, which is going to give me 3, plus the 5. So we can say that y will be equal to 18 minus 24 plus the 5, which gives me that y is equal to 23 minus 24, and that's going to give me now that y is equal to minus 1. So all we need to do is simply write the coordinates, and we've got now the y coordinate as minus 1. So just writing it here, we can say that y is equal to minus 1. Therefore, the point now Q, just writing the point Q, we're going to have 9, minus 1. So for the last part of the question, we're given 5 marks.